Hello everybody. Here in this lecture, we are going to focus upon the conductometry. So in the conductometry, we'll first see what is a conductivity cell, its construction and the care. Okay. So a conductivity cell is used to measure the conductance of solution. Why we are measuring the conductance of solution? To do the qualitative and quantitative analysis of any substance. Okay. So the solution is placed between two platinized platinum electrode of the area cross section A and separated by distance L. If you see in the diagram, these are the platinum electrode. The area of cross section is A and distance between them is L. First, the cell constant is L upon A. The cell constant is the distance upon area, okay, of the conductivity cell is determined. So cell constant of a conductivity cell is first determined. The conductance of an electrolyte solution of a known specific conductance is measured. Usually 0.1 molar KCl is used for determining the cell constant. So table given below gives the specific conductance values of KCl solution for different concentration. If you see, these are what the different concentration of KCl solution, okay, and for which these are the available values in Siemens per centimeter or Siemens per meter. Okay, so these are what the values of conductance, specific conductance, okay, for the different concentration of KCl value, and these values are helpful for the further study. Okay, so what is the cell constant? Cell constant is K upon G. So where K is specific conductance. K is a specific conductance of KCl solution. G is a conductance. So the conductance of electrolytic solution under study is then measured. Using the measured value of conductance, we can find out the specific conductance, equivalent conductance, and molar conductance of solution. Okay, so in conductance studies, the use of direct current is avoided as this will lead to change in the concentration of electrolytic solution due to electrolysis. Further, the electrode may get spoiled due to the product of electrolysis. An AC current about 50 cycles per second or 1000 cycles per second is generally used in this experiment. Okay, so there are two types of conductometric titration. Electrometric method is there and optical method is there. In the electrometric method, electrical properties are measured, and in optical method, absorbance of light is measured. Okay, so that helps us for the qualitative and quantitative analysis of any substance. Okay, so okay, the basic principle: when a solution of one electrolyte is added to the solution of another electrolyte, so without changing much volume of other electrolyte, the conductance of solution will alter. Conductance of that solution will alter if an ionic reaction occurs. Okay, if an ionic reaction occurs, conductance will alter. If no ionic reaction takes place over there, then the conductance of solution will simply increase. On the other hand, if an ionic reaction occurs, the ion added may replace the another ion and hence bring about the changes in the conductance. Okay, so here below some example they are giving over here, the addition of NaOH to the HCl and how the conductance is affected. If we see here, initially the conductance was more for HCl, but when NaOH is added, the conductance is get decreased. Okay, so what happened here actually, see, overall scenario, what we can say, the basic principle of conductometric titration is change in the conductance of solution due to difference in the ionic conductances, due to difference in ionic conductance, or due to production of more number of ions in the solution. Okay, due to production of more number of ions in the solution. Both factors permit the location of the equivalence point by conductometric titration. Okay, so what is experimental setup for the conductometric titration? Here in conductometric titration, what happened? We are going to take a burette, we are going to take a pipette, then we are going to take a flask or beaker. Okay, so to the titrant we are going to add titrant, and with the addition of titrant, with the help of micropipette, we are going to measure the conductance of solution. Okay, whatever changes occurs over there in the conductance, that we are going to report with the each addition of the titrant. Okay, so what we can say that near the equivalence point, we can find a sudden change in the conductance of the solution. Okay. So when titrant is 10 to 20 times more concentrated than the analyte, the total amount of titrant added is less and the dilution effect are insignificant. Okay, no problem. However, if this is not the case, it may be necessary to apply the volume correction and calculate the corrected conductance. Okay, so this is very important. Okay, to find out the corrected conductance. If the starting volume is V and the volume of titrate added is small v, then the corrected volume of a given solution is given as V corrected is equal to, so starting volume plus volume of titrant added upon starting value. This will be the corrected volume, and accordingly we can find out the corrected conductance as a G dash is equal to G into capital V plus small v upon V. G is a measured conductance, where this G is a measured conductance. Okay, so the corrected conductance G dash is plotted against the volume of titrant added. Okay, to get the equivalence point of the solution. So this is how whole experiment work. Okay, the assembly is same as like whatever we have studied seen for the potentiometer, but in this case we, as we directly measure the conductance, so there is a no need to have to be separate beaker. With in a single beaker with the addition of titrant from the burette, we can see the changes in the conductance. Okay, so conductometric titration are of different types that we are going to see. What different types are there? So first is the acid-base neutralization titration. So acid-base neutralization titration, we know that strong acid versus strong base is one type. Then weak acid versus strong base. Then strong acid versus weak base. Then strong base versus weak acid. Okay. Then weak base versus strong acid. So these are all what the types of titration which we can study very easily with the help of conductometry. Okay. So different acids and different bases reacts with each other, and their equivalence point can be easily found out. Okay. So even we can study the mixtures also with the help of this technique. Second is the precipitation titration. So titration of sodium chloride against the silver nitrate. Sodium chloride against the silver nitrate. There is a formation of AgCl and NaNO3. Okay, again titration of barium hydroxide against the magnesium sulfate. So formation of barium sulfate and magnesium hydroxide take place over there. This titration can also be studied with the help of conductometric titration. Okay, again complexometric titration. So solution of metal ion is stirred against the solution of complexing agent or the ligand. So as the titrant is added, the concentration of complex increases while it reaches to the maximum at the equivalence point. Beyond the equivalence point, the solution contains the excess ligand. Okay, the nature of the titration curve will depends upon the conducting power of the complexing agent and the ligand. Okay, so which is formed over there. Okay, so what are the application of neutralization titrametry? Okay, now see here the titration of strong acid against strong base. This is what the first application. So HCl against NaOH. What we see the here in this titration, the first conductance is decreases. Okay, when neutralization is complete, further addition of base results in increasing the conductance of hydroxyl ion are no longer used up for the chemical reaction. At the equivalence point, therefore, the conductance of the system will be have minimum value from which we can find out the equivalence point. So this point, okay, where the crossing takes place, from where we are going to plot one line on the x-axis. On the x-axis, we are taking the volume of titrant added. Okay, over where we will get the V equivalent or volume of equivalence point. Okay, so in the second case, titration of weak acid against strong base. Weak acid is acetic acid, strong base is a NaOH. Okay, when weak acid such as acetic acid is titrated against a strong base like a sodium hydroxide, the form of the titration curve is as shown in the figure at the left side. Okay, so initially conductance of weak acid solution is low, and the addition of base may be at first result in the further decrease in the in spite of formation of salt. Okay, the sodium acetate having high conductivity power. With further addition of the base, the conductance of highly ionized salt soon exceeds that of the weak acid, which itself or which it replaces, and conductance of the solution increases. After the equivalence point, there is a further increase in the conductance because of the excess of free acetate ion in the solution. So what happens here? So you can see here further, initially it appears like this, okay, from here to here, okay, and then later on you will get a sharp change over here from this point, okay. It is here only, okay. मला थोडंसं draw करताना problem येतोय. So from this point we are going to plot one line on the x-axis, or where we will get the equivalence point, okay. And with the help of that equivalence point, we can find out the actual concentration of the solution, okay. This is how that is possible. The titration of weak acid against a weak base, so acetic acid and ammonium hydroxide. So what you are observing here, again, as like a previous one, whatever the case of acetic acid was there, but see what happens when weak acid such as acetic acid is titrated against the weak base like ammonium hydroxide. The formation of titration curve is here in the left hand side. Initially conductance of weak acid solution is low, and the addition of weak base may be at first results in the further decrease in the conductance in spite of the formation of salt, and that is ammonium acetate. With further addition of the weak base, the conductance of highly ionized salt exceeds that of the weak acid, which is replaces, and as a result, the conductance of solution increases. After the equivalence point, there is a practically no increase in the conductance due to the addition of excess weak base, which has low conductance. Okay, the point of intersection will give you the equivalence point. Okay, so from here, if we put a line on the x-axis, that point of intersection will give you the equivalence with the volume at the equivalence point. Okay, so at the last, titration of strong acid against the weak base. So strong acid against the weak base. See what happens initially. So with the addition of titrant, the conductance decreases, and again further after the equivalence point, with the further addition of the weak base, then what happened here? The conductance increases. But the point of intersection from where we are plotting line on the x-axis, that is what our equivalence point. That is what our equivalence point, and that volume will help us to find out the actual result. Okay, this is how the titration of strong acid and weak base works. Okay, but remember here, in case of only weak acid, the graph appears quite different. Okay, it goes down and then comes up. Okay, at the both places you can find here acetic acid is a weak acid, the graph appears somehow different. Okay, not a straight line. Now titration of strong base against a weak acid. So you are taking strong base and you are adding weak acid. Okay, you are not taking weak acid here, you are taking strong base. Okay, hence what happens initially, the conductance goes on decreasing, but with the further addition of the weak base, the conductance start to increase. Okay, and that is due to the the ions form over there, and the point of intersection from which we are plotting line on the x-axis, that is giving us a equivalence point. That is gives us a equivalence point. Okay, and always remember on x-axis we are taking the volume of titrant added. Okay, the reaction you can see in over here, there is a formation of two ions, one ion, the salt ion, okay, or I can say a formation of a salt, okay, from the two ions, that is acetate ion and sodium ion, acetate ion and sodium ion. Okay, as a strong base is neutralized, the hydroxyl ion OH minus ion of the base are replaced by the less conducting ion like acetate ion of the weak acid. As a result, the conductance of solution decreases till it reaches to the minimum value. When the strong base is completely neutralized beyond the equivalence point, further addition of weak acid produces practically no increase in the conductance of the solution, as weak acid has a low conductance, and conductance increases with the very slow rate if you observe, or that is equivalent to no increase. Okay, so from here there is a sharp down is there, but from here the no sharp down, no sharp up is observed. Hence we can find out the point of intersection, the equivalence point of titration. What are the advantages and limitations of conductometric titration? So it is used. It can be used for the colored solution. Then the method works equally well for the diluted solution, as it is based on the changes in the conductance rather than the absolute value of conductance. Rather than the absolute value of conductance. Okay. Now the next. In conductometric titration, it is not necessary to make observation around the equivalence point with the addition of small increment of the titrant. Okay, so extremely weak acid or weak base can be titrated conductometrically, and that is not possible by normal titrometry. A mixture of weak acid and strong base can also be titrated with relative ease. Okay, so some certain limitations are also there for the conductometric titration. Overall accuracy of conductometric titration is limited, as the technique does not permit the addition of small increment of the titrant. Okay, the equivalence point cannot be determined accurately in case of dilute solution. This is what the limitation. Then in the precipitation titration cannot be performed very accurately with the help of this technique. Why? So slow separation of the precipitate formed during the titration and absorption of the ion in the solution on the precipitate. Absorption of the ion also in the solution on the precipitate. This is also a problem over there. Okay. So this was the last point from this unit. Okay. This unit is over. So third unit I will continue from the next lecture. Thank you.